If you want to learn quick and easy ways to solve math problems, please like and subscribe to my channel.
Our learning targets for today: at the end of the lesson, you can truly say that I can explain and apply the laws of integral exponents in simplifying expression with rational exponents. Let us first analyze this video.
Let's face it, rules take the fun out of everything. Rules and regulations make it so that we can't just do whatever the hell we want without consequences. Without laws, you could take anything you wanted from someone else. You could drive as fast as you want without a seatbelt. You could also hurt whoever you want. But rules also protect us from a lot of things. They ensure a standard of morality for ordinary people. Without them, our society would plunge into chaos. But
watching the video, we learned that laws govern our life. They provide natural order on how things behave around us. These laws also provide opportunities for us humans to be innovative. Example of these laws are the law of gravity, laws of motion,
Start, 2, 1, booster ignition, and liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond.
and gas laws.
We are the gas particles and we're inside a box.
The world, each nation also have laws that govern how each citizen should behave accordingly. In mathematics, numbers and operations are also governed by laws that we need to follow. We will discuss and apply some of these laws today. I want you to remember that every law originates from the divine laws of God. And these laws were made for our own good, our guide for us to arrive at our right and ultimate destination, heaven. Last time, we studied how to determine if an expression denotes a real number by looking at the two important parts of this expression. Let us have some more examples today. 128 raised to the power of 1 over 7 equals quantity 2 to the 7th power raised to the power of 1 over 7 equals 2 raised to the power of 7 over 7 equals 2. Quantity negative 27 over 125 raised to the power of 1/3 equals quantity negative 3 over 5 cubed raised to the power of 1/3 equals negative 3 over 5 raised to the power of 3 over 3 equals negative 3/5. All our examples denotes real number. By the way, real numbers are numbers that are found in the number line. Examples are fraction 5 over 3, decimal 63 hundredths, radical square root of 3, negative 101, and positive 20,000, and many others. Now let me present the laws of integral exponents. These are: number 1, product rule; number 2, quotient rule; number 3, power rule; number 4, power of the product rule; number 5, power of the quotient; number 6, negative power; and number 7, zero power. Let's apply these laws. Let's start. For example, x raised to the power of 1/2 multiplied to x raised to the power of 1/3. X to the 1/2 times x to the 1/3 equals x, and the exponent 1/2 is added to 1/3, resulting to x raised to the power of 5/6. In this example, what operation is involved? Do we have the same base? What did we do with the exponents? To multiply expression with the same base, just add their exponents. This is called the product rule. Let's divide x squared by x raised to the power of 3/2. So x squared divided by x raised to the power of 3/2 equals x, and the exponent 2 is subtracted by 3/2 equals 2x raised to the power of 1/2. What operation is involved? Do they have the same base? What did we do with the exponents? To divide expression with the same base, just subtract their exponents. This is called the quotient rule. Quantity x squared raised to the power of 1/4 equals x, and the exponent 2 is multiplied to the other exponent 1/4, resulting to x raised to the power of 2/4 or x raised to the power of 1/2. How many bases do we have? How many exponents do we have? What if we have 3, 4, 5 exponents? What did we do with the exponents? If you have an expression with 2 or more exponents, simply multiply these exponents. This is called the power rule. In simplifying quantity xy squared raised to the power of 2/3, in this expression, x has an exponent of 1. This is multiplied to the exponent 2/3, and y with an exponent of 2 is multiplied to 2/3 also, resulting to x to the 2/3 and y raised to the power of 4/3. How many bases do we have? What if we have 3, 4, 5 bases? How many exponents do we have? What did we do with these exponents? If you have an expression with 2 or more bases, the exponent of each base is multiplied distributively to the other exponent. This is called the power of the product rule. Quantity x over y raised to the power of 1/4 is simply equals x raised to the power of 1/4 over y raised to the power of 1/4. How many bases do we have? Is our base a fraction? How many exponents do we have? What did we do with the exponent? If we have expression with a base which is a fraction, multiply distributively the exponent to the numerator and the denominator of this fraction. This is called the power of the quotient rule. Another expression, x raised to the power of negative 2/3, is simply equal to 1 over x to the power of 2/3. How many bases do we have? Is our exponent negative? What did we do with the exponent? If you have an expression with a negative exponent, just apply this rule by placing the expression in the denominator of the new fraction expression whose numerator is 1. By doing so, don't forget to make the negative exponent positive. This is called the negative power rule. Negative exponent happen when dividing expressions where the exponent of the numerator is lesser than the exponent in the denominator. Example, y raised to the power of 1/2 over y raised to the power of 2/3 equals y raised to the power of negative 1/6, or simply 1 over y raised to the power of 1/6. In addition, x to the power of 1/2 divided by x raised to the power of 1/2 is equal to x raised to the power of 1/2, where the exponent 1/2 is subtracted by 1/2, resulting to x raised to the power of 0 equals 1. What is the operation involved? Is the numerator same with the denominator? Why exponent becomes 0? What happened to x with 0 exponent? An expression with 0 exponent will appear if we will divide the same or identical expressions. 0 exponents will always be equal to 1. This is called the zero power rule. To sum up what we had today, we were able to explain the laws of integral exponents. That's all for now. Stay safe, stay connected to God. See you next time in a more fun, collaborative, and meaningful math experience. God bless!